Yeah. So like you said, my name is Chris Anthes. I am the founder and CEO slash CTO of Happnen. Little on my background, I've been professional software developer for about 32 years now. And my very first startup company was about 20 years ago. And we were building what was at the time that the term didn't exist, but it was a graph database. We were building, me and my business partner had realized that there were problems that we were trying to solve in software that was really, really difficult with SQL databases, which were what pretty much was being used at the time. And so we started a startup company and with an idea to build a database that allowed us to connect data through relationships. Um, Turns out I didn't really know anything about what I was doing at the time, and so after a couple of years, we wound up not quite getting it off the ground. But that stuck with me for a long time, and as I worked on different projects throughout the years, kind of have always gone back to this idea of being able to build out the data, the underlying data, uh, in a different manner. Um, so over the years, I've tried different NoSQL databases. I've tried document databases, but ultimately, I mean, the graph database is really for a lot of the kinds of problems that I try to solve. Seems like the graph database really offers up a lot of unique ways of managing data. One of the primary ones is the um, the flexible schema and the ability to build things out. So, anyways, Happnen is my company right now. I've been doing Happnen now for about 7 years or so. I will say the first version of Happnen was built in Ruby on Rails with a SQL database, but I wanted to use a graph database for a long time, and turns out now the tool set is there that allows me to do that. And so I'll tackle the first question everyone asks, which is what's Happnen? Um, so Happnen is a application that helps people discover local live entertainment. So whether it's music, comedy, dancing, DJs, theater, karaoke, burlesque, whatever people are looking for, we list it on Happnen, and people can go in and find it. Right now, we're just in San Diego. Like I said, I've been running for a few years, but I rebuilt the entire backend in Neo4j and relaunched it this year after COVID kind of shut down live entertainment for a bit. Um, but our goal is to build a platform in which artists and venues can promote their entertainment and for people to find them and make it out to those shows. So because we're building a platform, it's a consumer facing application, but it has a lot of issues with data in that data is going to be coming from a lot of different sources. Artists are going to be putting in data, venues are going to be putting in data, users may be putting in data. And so the ability to make sure that that data is very well organized and structured, but also flexible enough to allow different types of data to be entered is sort of a key element. And it's one of the reasons why I switched to a graph database. So currently, GRANDstack is what has allowed me to build out Happnen. It's all built in TypeScript with React, Apollo, and Neo4j, and the GraphQL. Relatively new. I think it's been about 2 years now, maybe. So GraphQL library that links up with Apollo. So that's Happnen. So I guess the subject of my talk, this kind of came about. I was chatting several months ago with my buddy Jason, and we were talking about using a graph database and why I had chosen to use a graph database for Happnen, and kind of came up with this concept about. I talked with him about a lot of times graph databases are thought about for these big data problems, right? People are putting them on solving these things that are dealing with tons and tons of data, and we'll put that into a graph and we'll be able to navigate through the graph. But there doesn't seem to be a lot of push for building more consumer facing applications using Neo4j or other graph databases. So this kind of idea of looking at the kind of problems that you might want to deal with a consumer-facing application and how you might apply a graph database to go about solving those. And threw out some ideas, and we kind of chatted back and forth, and it's sort of evolved into this, hopefully what will be interesting in this talk. This is an intermediate talk, I think, so most people kind of know the basics of a graph database and differences between SQL, but just kind of refresh. I mean, SQL databases have been the standard for a long time. They have advantages in that they have really sophisticated tool sets. I think most application frameworks these days are built to run on top of some form of SQL database. They handle data integrity really, really well, and they're just familiar. Everybody knows SQL databases. So the other forms of NoSQL databases, document databases, and a few others, documents, I think, are really the main ones that most consumer applications utilize. While they're not SQL databases, they have some inherent problems, mainly around the fact that they don't really manage relationships well. And no matter how far you go in an application, at some point in time, you're going to have data that needs to relate to other data. And if you've ever built a fairly decent scale app on top of something like MongoDB, you find out that soon you need to manage relationships, and that becomes very difficult because you have to manage them all yourself. There's not a lot of tools built in, and you can get relationships that get out of sync where one thing thinks it's related to something else and then it's not, and you have to go and manually update these records. And one of the things that I like to talk about with a graph database is that graph databases aren't, they're actually more relational than SQL databases, in that the relationships themselves are actually stored in the database. And so you don't need to query for the relationships. You don't need to kind of understand what the schema is in order to figure out what data is connected to other data. So again, hopefully most people here are somewhat familiar with this, but basically when it comes to building out an application using our graph database, I think there's a couple really key elements to me for building consumer apps on a graph database. And the first one is the ability to apply multiple schemas to the same data. So you can start with a very low structured schema, and then you can start to, as you build your application out, you can start to add more structure to that. And one of the really cool things I think that you can do in a graph database, and we'll dive into a little bit later here, is that you can apply multiple schemas. So you can actually take an existing schema and then decide that you want to add more complexity to that. And by just adding additional relationships and nodes, you can actually make the schema more sophisticated without having to basically roll out really change the data that you've already got in the system. And then the other thing is persistent relationships. I think that really makes a huge difference in the ability to build out applications that kind of grow over time as the needs of users become more apparent and you're adding additional features, trying to keep up with the needs of those users and not having to go back and rebuild schemas and redefine new relationships. So I'm going to try to come up with a way of discussing this, and I just kind of came up with this idea for maybe like this pseudo networking, or maybe a social messaging app, the latest generation social messaging app that you might think about building. I actually did this a couple of years ago. I had an idea for something. I had looked at Slack and Twitter and Facebook and a lot of these different apps and thought that there was a way of taking bits and pieces of them, and if I used a graph database to manage the content, really make a more user-friendly, user-structurable, flexible way of handling messaging and communication. So this is my kind of little mock-up here, Squeaker. And so the idea behind this is we're going to take the notion of building say a simple messaging app or a social messaging app kind of from the start. So way you would build this out in a graph, I mean, very simple. You'd start with just a user node and maybe a message node, and you'd create a you'd have a relationship where the message was created by the user. And so now the user can generate multiple messages and they can push them out there. And fairly simple. But then let's say you add more users, and the users not only just want to read the other person's messages, they want to be able to reply to them. So now you can have multiple users that are still adding messages to the system, but by adding simply one relationship, you can now build these message threads that kind of go back and forth. And so now you've added a little bit more structure to your messaging without having to really kind of rebuild anything, and using the existing structure that you had. But I think this can be improved upon. Let's say you have different topics that you kind of are talking about. And now it becomes difficult to kind of manage where the topics are, and you want to be able to go in and search for certain topics. So one way you might go about doing that would be to just take your existing schema and then just add a new node, a topic node. And you could use that node to then connect a message to a topic. And now that entire thread of messages is now organized by that topic. And so you can go in and search on that topic and find that. And as you add additional topics, one thing I've always thought you should be able to do with, say, like Slack or something, is actually add the same message to multiple topics. So you might have Slack, you got your channel, you can copy and move messages and add links, but sometimes a message just belongs in multiple channels and you don't want to have to go post it. So here you can very easily just add additional topics and just link that message. And so it doesn't matter which topic you're viewing, this message would appear in that topic. And you could even go so far as to say that maybe a part of a message thread, sort of a sub thread, actually kind of created another topic. And so the original topic that the message thread was about might not be applicable, but there might be a new topic that kind of spawns off of there. And so being able to take even just an existing message in a thread and move that into a separate topic, and now you can have an entire conversation that goes around that without having to, again, copy and move data around and decide that, oh, I'm going to move this message out of this thread. So it's an example of being able to take an existing schema and add a little bit more to it and then view it in a new way. So another thing that I really love about I don't love a lot about social networks, but one of the things that I think really helps kind of tame them a bit is hashtags. I think hashtags are great. The ability to add free form hashtags to content and then be able to go and search off of that. So again, in this scenario, we can take our existing schema and now just add some hashtags to it. Now we can apply those hashtags to various messages. And even in a situation, you might even apply a tag to a topic. So when you're searching on a given hashtag, you can find topics that are related to that, as well as message threads and anything else in your system. And again, we've just added new structure on top of our existing data. So I think this is fairly straightforward now, nothing super complex. You can handle some of this stuff in a SQL database or in a document database. It just a lot of times you wind up having to add more structure than you really kind of plan out in order to get some of this stuff working. And then if you don't add the structure exactly the right way, then you wind up having to go back and refactor and run mutations or run migrations to update your data. So another example of how this could be handled. So let's say we take our example here of having tags, and someone creates some messages and they add some tags to a message and they add a tag to a topic. But another user comes along and they don't agree with the tags in this system. They don't agree that this message should be tagged with this, or they don't like that tag and they don't want to use that tag. So how do you deal with that? Well, one way would be to make the tags now belong to a specific user. So when a user adds tags, instead of them just being generic tags that everybody has to agree upon and use, that user can create their own set of tags and apply that. to data in the system, and then another user can come along and create their own tags and apply their sets of tags. And this gets into some of the thinking about things like taxonomies and folksonomies. So taxonomy is an agreed upon structure. Maybe if we're categorizing some music, we could all agree that, you know, Charlie Parker is a jazz musician, right? And Muddy Waters is blues. But then I might have music that makes me feel happy or sad or feel in some way. So I want to create my own folksonomy. I want to create this set of categorizations that I want to apply to things that maybe is only my categorization, doesn't apply to anybody else. And so I don't want to have to enforce that on other people. So I can build out my own set of categorizations. And then let's say we had another user come along and they kind of don't really want, you know, they don't want to create their own set of tags for everything and have to go in and tag everything. But turns out they kind of agree with user one, some of the tags that user one uses, and they agree with those. And they see some of the tags from user two, and they agree with how that data is structured. And so what they really want to do is they want to kind of connect they want to kind of borrow those tags or maybe even subscribe to those tags, right? And so what they can do is now you can go in and they can add their own tags, and those tags can just connect to another user's tags. And so instead of having to copy tags and copy all of these different things, you can just add a new relationship that allows you to connect your tags with someone else's. And for me, like, I find one of the things I've always really kind of wanted from Twitter was this ability. I had people that I would follow on Twitter, and sometimes I would want to go in and really what I'm interested in is the way that different people curate messages on Twitter. So I wouldn't want to go search for a given hashtag and see everyone, you know, there's going to be a lot of people who may have tagged stuff that I'm just not interested in. I don't care what they do, but there are certain sets of people that I am interested in what they tag and how they organize their data and how they curate data. And so what I'm really looking to do is subscribe to them and have them be sort of a curator of information. And again, I think with a graph database, this kind of being able to add these kind of features, you can kind of try things out, throw it in there, not really, you know, if it doesn't work, you don't have to kind of roll back systems. You just start ignoring relationships and just don't use them. And your data still exists in the same way that it did before. So I'll go back to another problem that, you know, Squeaker doesn't have, but Twitter, a lot of people have complained about for years on Twitter that you can't update a message, right? So there's systems out there, there's messaging systems that will let you update a message. But let's take this problem here. So user Dylan goes in, finds a topic, favorite bands, and posts a message saying, "I love Wolfpack." Great band. Totally agree with Dylan. Sally comes along and Sally agrees with Dylan as well. And Sally replies to Dylan's message and says, I do too, right? But now Dylan, being a sneaky one, they decide, well, actually, I'm going to change that. And they're going to update their message to say, "I love Nickelback." Now Sally's kind of looking the fool, right? Because she replied, "I do too," to Nickelback, and Nickelback is not what she meant to reply to. So it's not it's a relatively simple problem, but this does come up in some systems where you can go in and edit messages, and it is a problem that you can look at and say, well, there's a lot of different ways of solving this. As a developer, I think one of the patterns that we've utilized over the last several years is immutable data. Immutable data is a way of handling some of this, and so I think Graph presents itself as a really excellent way of utilizing immutable data to deal with situations like this. So if we go back to our original message, we can say that we can post a message. So Dylan posts this message in the favorite band topic, but now we pull the content of the message out and put it into a separate node, and we link that content to the message. And so now the message is still attached to the topic, and then when Sally comes in, when she adds her message is actually a reply to the content for the message. And then if Dylan decides that they're going to change their message, what they do is they can simply just add a new node and then just move. You can kind of see, you just take the content for relationship and you just move that to the new node, but then link it back. So for a given topic, you can still see the entire thread history. You can navigate through it. And as far as presenting that to users, you can choose whatever way that you might want to show that. You might want to show a history. You might want to kind of hide Sally's comment. You know, it really depends on your user experience. But by simply taking the same data and just kind of adding new relationships and then maybe being able to move the relationships around, you can kind of build out this thing. And I think the idea of persisting data in the database in an immutable manner, where you can simply connect to previous versions of that data, so you can keep this history of things, of transactions that have gone on, but really have the data that you're concerned with, that you care about right now, is kind of upfront. And this is a pattern that I actually am using in Happnen and plan to use down the road for a lot of the content that a lot of the data that I store in Happnen, because it gives me the flexibility to allow for users to change data without necessarily worrying about whether those changes will impact anyone else. Yeah, so there's a question about the message pointing to the user. You could kind of go in either way. I kind of feel like the relationship I would put there would be a created by relationship. So the message was created by the user, and then the content as well would be created by the user. So I would have a created by relationship. I kind of took some of the relationships off of these just because it can get really difficult to read. But that's how I modeled out that particular node in this case. So anyways, I know this is probably short. I wanted to leave some time for anyone who wanted to ask questions. I also want to, I think there's some things Jason and I kind of touched on. So again, I think flexible schemas is a big strength of graph databases. And there are these trends that are moving towards these no-code frameworks, right? And in my opinion, one of the biggest weaknesses of no-code frameworks is that if you start building an application using a no-code framework, you're kind of tied into the structure and the schema of the data that the no-code framework uses. So most of them have these kind of SQL schemas that they apply as you're storing data. And then if that schema winds up not being able to support what you need, you wind up being kind of stuck where your no-code framework maybe doesn't allow you to go in and update that. And it may be a while down the road, but I think an interesting idea to maybe look at would be utilizing a graph database and building a no-code framework on top of that, where the no-code framework actually allowed you to be more flexible in your schema and be able to build out different schemas, through that framework, as opposed to being kind of stuck into the way that the no-code, the fixed schema that the framework is built on. So I think there's a lot of different directions when you start thinking about how to model data a little bit differently than you would in, say, a SQL database, and thinking about how to kind of build schemas on the fly as you build out additional features. So anyways, I don't know if anyone has any questions, but anyone wants to jump in and ask anything. By the way, that's my email address and my LinkedIn if you want to get a hold of me. My Twitter is no longer, I'm one of those that's not expecting Twitter to be around much longer. It seems like it's spiraling down quickly, so I kind of deactivated my Twitter account. But if you would like to get a hold of me, you can reach me at that email address or at LinkedIn. All right. Well, I think that's probably looking out, see any other comments here. So don't know if our host is still around. I don't even know how to see. I'm assuming there are people. Yeah, Twitter is Twitter is a funny one. I think the original founder of Twitter, Jack, he's talked about where he feels like Twitter would work best as an open source sort of platform where one company wasn't in control. I think that, again, if you're building a social network today, building some sort of system that's open source where people can come in and contribute to how it works and not necessarily controlling all of the data. I didn't get into things like encryption and some of the schemes that I've thought about as far as storing data within that database and being able to share it with the people that you want. I felt that was a little kind of too far out there for this talk, but basically, shared keys, RSH keys, and being able to have shared keys and being able to store your data in the system encrypted, but having relationships that themselves are not encrypted is another really great scenario for a graph database where you can know sort of the context of some data that's stored in the system, but the actual content of that data itself could be entirely encrypted and could only be decrypted by users who had the appropriate keys. And maybe you issue keys to various users that they store in their vaults and can use that to unlock data. So yeah, so pattern used in so I think I was maybe talking about the immutable data and being able to persist data and then be able to go in and make changes to that data no matter what your data is, being able to make changes to that data by simply putting a new version of that data in and then redirecting the relationship that points to that data to the new copy, and then having that copy point back to the old one. And that pattern, the great thing about that pattern, I think, is that you can persist that data, you can keep that history, but you don't necessarily have to do anything with it. Your application wouldn't necessarily even understand or know that there were different versions of that data because it's just loading the current version. But it's a way of being able to persist data and use immutable data to store copies of data without having to rewrite your app so that it knows about these, this historical, the way that you're storing historical data and going back and loading it. So I think it's if you build your application off of Neo4j or another graph database, I really like the idea that you can, without changing the schema that your current app is using, you can go in and start changing the way that your data is structured in the back end, and then build out new views on top of that utilize that structure. And then if that structure works out, then you can kind of switch your front end or your main application over to utilize the new structure or include new features. And another thing didn't talk about is being able to deal with feature flags and things like that. I mean, there's a lot of different patterns that are used in development, but I think graph databases, again, kind of the fact that, to me, a SQL database, like if I want to change the structure of a table in a SQL database, being forced to, I either have to kind of copy that entire table and then change the structure in that table and have two copies of that table, one that's being used by one set of features and one that's being used by another set. Whereas in a graph database, by just adding additional relationships, you're not changing the existing structure of any of that data. And now you can add additional features on top of that. I think that maybe that was the pattern I was kind of talking about. Yeah, so the idea of too many messages. Thank you, Marilee, by the way. I do like my album covers as well. So yeah, these are some of the interesting problems. So the idea of tags, right? If you just had a single hashtag in the system and things just got tagged, how quickly would you overload the relationships for that tag? I have the same problem. I mean, Happnen, because so much of our content is timeline based, after an event occurs, I want to retain the data for building out recommendations and things like that, but that data becomes less relevant as time passes, right? And so the idea of maybe adding a node in between, and so being able to take the existing data and split it up and add nodes in between as sort of connector nodes. And then so what you wind up doing is you can kind of split those relationships out to multiple nodes, and then use the multiple nodes as kind of gateways off to the data that you want. I think depending on the type of problem you're looking to solve, or the type of data that's being stored there, there's a number of different patterns. But again, I think that the super node problem definitely is one that that as you evolve your data can be something that you have to look at. And I think being able to then, one of the nice things, again, because the relationships in a graph database are persisted, by adding additional relationships in between there, if you build your queries right, Cypher, you can jump over nodes. You can basically go from one node to another node and look for a given relationship in there, but not kind of care what the other relationships are in between. So you can kind of split these nodes up and kind of cluster them in a way that would allow you to kind of optimize that data over time without necessarily breaking everything. But it is something that I think I think it's a problem that is interesting to think about and try to come up with solutions. I think in the SQL world and in say document databases and things like that, those problems become a lot more difficult to handle, I think, because if you are, say you're taking your database and you're going to segment your database into multiple databases, now you're having to completely redo the entire structure of your schema to shard data across different clusters. Where in a graph database, I'm not sure that Neo4j necessarily has this solved yet, but being able to kind of put additional data in between your relationships that would allow you to then kind of cluster it off in different areas without necessarily breaking those relationships and having to rebuild them. So. Okay. Well, I think that's it. Thanks everyone who came. Hopefully found it interesting and some ideas that you might take with you. I'm looking forward to the next generation of consumer applications that are all built on top of graph databases and are much more friendly with the way that they deal with data. Thanks, everyone.